Okay, today we're going to talk about solving one-step equations, page number 63 in your text, so make sure that you're there and you're looking here over the next couple of pages. An equation is a mathematical sentence stating that two expressions are equal. It may not mean a lot to you, but it will in the sense that we always have to have balance. Okay, whatever we do to one side of an equation, we do to the other. And algebra is really about finding the unknown, right, the variable. And your book's got a lot of different things here in relationship to inverse operations and so forth, but I'm going to actually try to get right into it and show you here on the next page some of the different examples of the equations that you'll be working on in this particular lesson, okay? So the first thing we're going to look at is a problem that looks like this. X minus 12 is equal to 15. Now, you might remember back in your elementary days, actually when you were younger in elementary, you might have seen things like this, all right? It was on your paper, it was a nice color, and you were doing seat work and so forth. And in doing that, you had to fill in what basically the box is, okay? And you had really, really simple ones, and those simple ones obviously would be a 1. 1 plus 2 is equal to 3. Well, we're going to finally get into the official way, and this is kind of a review of what it is you need to do to always find x and to find it properly. Now, the title of it is one-step equations. That means, if we spell it out, that means EASY. Easy, yeah, that's what that means. One step, that's all you got to do. Then we're going to move on to, what do you think's next? Oh yeah, 2 steps, yeah, because that comes after 1. And then maybe in algebra you'll get to 3, I think you will, in algebra 1. And let's see, algebra 2, you'll probably pick up right away with equations that are probably no less than 2 or 3 steps. You'll find equations with 4 and 5 and 6 steps. I think there's some that might be 7 or 8. Might be some advanced math that might be 10, 11. It happens. So what you need to do is get the right answer and just follow the rules and follow the step and do the math right. It isn't anything that ought to scare you, but you still need that sticky note, okay? The paper that we showed you as far as how to add and how to subtract signed numbers. Well, let's do the easiest one we can, okay? Now, the inverse operation, so right here we have an x, don't we, okay? The x is on the left-hand side. So that means everything on the side of x, we need to move over to the other side. Because we always want x to be by itself. That's what we're striving to do, okay? Well, x is not by itself, and there's a big, ugly negative 12 there that needs to be moved to the other side. And when we move it to the other side, bam! We found out what our answer is because one-step equations. Okay? Well, what is the opposite of a negative 12? What is the opposite? Positive 12. So you would say to yourself, what is the number and the sign that if I put under this negative 12, cancels it out to be absolutely nothing, blows it into smithereens, and it's not even there anymore? Well, the opposite of a number, if it's negative, is positive. Or if it's positive, is negative. We learned that a few lessons ago. So the opposite of a minus is a plus. And a minus and a plus balance each other out. But if I put 11 here, I'm going to get a negative 1. If I put a positive 13 here, I'm going to get a positive 1. Do I want anything left over next to my x? No. I want my x to stand alone. Follow me. Okay? So if that's the case, I need to add exactly what the value is. Minus 12 would be plus 12. Well, whatever I do to one side of the equation, I have to do to the other side because to keep a balance. If I add 12 but add 13 over here, well, that's going to give me a wrong answer. So if I add 12 on the one side, I'm going to have to add 12 on the other side. All right? When you're doing your homework, you're going to write the equation, and in the second line, you're going to put down what you have to do. Okay? So in doing that, I'm going to put down plus 12 on the second line, and I'm going to write an underline, or just a line under it, and then I'm going to solve. So the x comes down here, all right? What's a minus 12 and a plus 12? Nothing, it's gone. Okay, beautiful. All right? 15 plus 12.
72.
All right, 15 plus 12?
27.
27. All right, now, what ends up happening is this. When you do your homework, follow me, when you do your homework, I want the x to be brought down right under the x. Okay? I don't want the x over here, I want it right there. X equals, and then 27, right in order. Look at this one over here, okay? I have an x plus 15 equals 11. Well, in this case, I don't have a negative number, I have a what?
Positive.
I have a positive number. What's the opposite of a positive?
Negative.
A negative. So I'm going to write down a negative and exactly what the value is. Well, if I do it on the left, I got to do it on the right. Okay? Okay. Well, look what happened. An 11 minus 15. We know that goes the other way, right? So we're going to be in the hole. Or 11 minus 15 like this. Or when we were studying it here a couple of weeks ago, everything is what kind of a world should we be living in? A positive world. So it's an 11 plus a negative 15. Well, the reality is either one. One's a positive and one's a what?
Negative.
Negative. So we subtract and we keep the sign of the larger number. So 11 from 15 is right around 4 and it's negative. Okay? X, and we carry our equal sign, and that's what I want to see. 3 lines. Just like that. Now we did the plus and minus. All right? Let's do one with a fraction. I know fractions can be a dirty word, but it doesn't have to be. All right? Watch, because you're going to have fractions. Ready? Plus 2/3. What do you think we have to do to get rid of it? Blow it to smithereens by doing the opposite of the number, right? Negative 2/3. All right? Well, the left side's real easy to do. All right? Now watch. Bring down our equal sign. Minus 2/3. We're going to minus 2/3. Okay? Same sign or different sign?
Same.
It's the same, isn't it? All right? So,
Positive.
technically though, watch what happens. All right? Let's do it this way because I don't want to trick you. But if I already have a negative 7/12, okay, and I subtract 2/3 from it, okay, I want to show you, like we did over there, all right, everything is a what kind of world? Positive world. So a negative 12 plus a negative 2/3. So both across as well as down, this is actually an addition problem. Do you see that? You have to be able to know from your sticky note whether you're adding or subtracting. And once you do that, then all you do is just take 2 fractions and just do what you normally would, okay? So least common denominator, 12 and 3, would be 12, right? Okay, what goes here? 7. What goes here? 3 times what is 12? 4? 4 times 2? 8. All right? Now, are we adding or subtracting? We're adding, and we keep the sign, don't we? So our answer is going to be negative, right? What's 7 plus 8? 15/12. All right? Now we're allowed to keep it that way, or we can write it as negative 1 and 3/12, which would be negative 1 and 1/4, right? We would reduce, we would leave it as 3/12. Probably just easier to leave it like that, okay? Now let's do 2 more problems and show you the opposite of the other operations, okay? This is x divided by 7, all right? Now if I showed you a simpler problem like this, x over 2 is equal to 4, okay? Well, what over 2 is 4?
8.
Right? Would be 8, right? Understand? 8 over 2, 8 cut in half is 4. Well, I can see it on a really easy problem, but more complicated ones, how would I do that? All right? Well, what is the opposite of division? What's the opposite? Multiplication. So all I have to do is multiply both sides by whatever the denominator is. See? What's the denominator? 2. What is 2 as a fraction? It's 2 over 1, right? So I multiply both sides times 2 over 1, or 2, and this cancels out. I multiply by the denominator because every single time, 100 times out of 100, you know what happens? This cancels. What am I left with? And I only want my x to stand alone. So the only thing left on the left side is an x. That's the beautiful way every single time Love doing it that way. What's 4 times 2? 8, so there's my answer. If I do it this way, all right, multiply both sides by what?
It's negative 91.
7, right? Okay, so let's multiply by 7 over 1, or 7, same thing, okay? 7 cancels, I'm left with an x equals, what's a negative divided by, or a negative multiplied times a positive?
Negative.
All right, it's a negative, isn't it? All right, so it's 13 times 7, 21 is what, 91, all right? So 91 is our answer, negative 91. Okay, there's our answer. Now, what's this 3 and this x next to each other mean? That means multiplication, doesn't it? What's the opposite of multiplication?
Division.
Division. So if I divide everything that's not x, it's going to cancel out perfectly, and I'm only going to have x left. So if I divide both sides by 3, this cancels, and x is equal to 33. Okay? That kind of helps me know. Now, in one particular instance, I'll show you this as well. If I have 3/4 x is equal to 1/3, okay? How do I get x by itself? Well, I don't just multiply by the denominator. I have to multiply. Watch this. All right. What do I multiply 3/4 by to make it 1? 4/3. So whatever the fraction is, I flip it and I multiply both sides by 4/3. 4/3. And guess what happens? The 3's cancel, the 4's cancel. That's called the reciprocal. When I do it that way, I get 1x or x every time. X is equal to, all right, and it looks like 4 over 9 is my answer, not 4/6. Okay, all right, understand? So that's what we have, all right? So that's how you do it. You basically just do the opposite of what the sign is.